Alright, hey guys. So we are gonna go over the review that you did in class yesterday, and I know it might have been easy for most all of you, but we had to start somewhere, and so Mr. Blackwell and I both gave all Algebra 1 this review and the pre-test that y'all be doing just to kind of see where we're all at. That way we know how to plan for the year. So we're going to go ahead and get started. Please follow along on your own paper, correct your answers, and hold on to your packet until I'm back next week, and I will go through that. You'll get a few different grades, and we'll talk about that later on next week. But let's go ahead and get started. So, on number 1 through 5, we are just writing an algebraic expression. So, first, let's talk about some important terms. So, on number 1, it says for less than. So, let's underline the word less. Excuse me. Alright, so for less than 15. So think in your head, if something is less, then like you're either adding, subtracting, multiplying, dividing. Well, if it's less than, you've got to be subtracting. So 4 less than 15. So that would be 15 minus 4. And if you wanted to, you could go ahead and solve that. So 15 minus 4 would be 11. All right, so out beside where you underlined less, I want you to write the word subtract. All right, number 2 is going to be the same way because it also says the word less. So 8 less than 8. 8 less than x. So x minus 8. So we really can't solve that one because we don't know what it's equal to. So x could be any number in this case. Okay. Now number 3, maybe a little bit harder, the word quotient. So think back to when you learned what the word quotient meant. So remember, that is when you divide. Okay, so if you are, let's say it in using the word divide, the quotient of 72 and 8 is the same thing as me saying 72 divided by 8 is 9. Or we could physically write 72 divided by 8 that way. All right, number 4, this time it says more. So we know anytime we see the word more, that means to add. So 9 more than 7 will be written as 7 plus 9 equals 16. All right, and then number 5, let me erase this right here where you can see it. The word product. Remember, the word product means to multiply. So the product of n and 10. So n times 10, you could write it that way. Now we don't know what n is, so we're not going to have an actual number. So you would just leave it as that in a case like this. All right, next on number 6 through 10, we are doing some orders of operation. So I want you to write on your paper P, E, M, D, A, S. And I know that you all remember that as please, excuse, my dear, Aunt Sally. So in a case where you have both multiplying and dividing together, or you have adding and subtracting together, remember you work left to right, okay? All right, so let's look at number 6. We have 2 plus 2 times 6. So we always want to do our parentheses first because that is where our P comes from. So if we simplify that, we get 2 plus, well, combine our parentheses. 2 times 6 is 12. Okay? Then we don't have exponents. We move on. We don't have multiplying. We don't have dividing. We do have adding. So 2 plus 12 is 14. Okay? Now, if you look at number 7, we have 2 sets of parentheses, but we've got one set where it has to be simplified. So let's go ahead and do the right side first and simplify it. So we're going to just bring this down. So we brought down our 2, and then we have 3 divided by 3, which we know is 1. Then we do our parentheses. 2 times 1 is 2. Now, I know number 8 is so hard for all of you. Just kidding. So, 5 plus 2 is 7. 7 plus 3 is 10. That was easy. No brainer, right? All right, number 9. So we have a parentheses of 5 and a parentheses of 2. And if you notice, there's a big set of parentheses around both of those. So you want to combine those first. So 5 times 2 is 10. Bring down what's left. 10 divided by 5 is 2. All right, number 10. So let's always do our parentheses first because our P comes first. So we have 1 plus 1, which is 2. And then it says 2 divided by 2 plus 5. So now we're going to work left to right. We're going to do our division because if you notice, division comes before addition. So 2 divided by 2 is 1. 1 plus 5 is 6. All right, next on numbers 11 through 15, you are plugging in values and solving. So, First on number 11, we are plugging in the number 4 for Z and the number 1 for Y. So it's going to look like this. All right, so think in your head, what does this mean? What does this 2 right here mean? Does that mean that I say 4 times 4 2 times? Do I say 1 times 1 2 times? Or does that mean that I write it like this? Yes. Okay. So I'm writing it 2 times. I'm simplifying. 4 minus 1 is 3. All right, and then we have 3 times 3, which is 9. So the answer to number 11 is 9. Now, if you use your calculator while doing this, that is fine. But I need you to be able to do this without your calculator as well. Your calculator should really only be used as a way for you to verify your answer, for you to go back and check, okay? So, when you take your pretest this week, I want you to try and use it without your calculator, okay? Then once you're done and you want to go back and check your answers, you may do so, okay? All right, so number 12, we have Z as the number 6 and 3 as the number Y. So we're just going to plug those in. So we have, let's see, 6 minus 3 divided by 3. Now, I know you've all seen those things on, if you have a Facebook, you've all seen those things on Facebook where they have math problems and they want you to solve them, and it's always the order of operations, and there's always so many different answers because nobody seems to remember that you worked left to right. So, first we're going to do, what? Think about this. Please excuse my dear Aunt Sally. Well, you notice we have division and subtraction. But which one comes first in the order of operations rule? Right, division. So we're going to do this first. So we just bring down your 6. Negative 3 divided by 3 is a negative 1. 6 minus 1 is 5. All right. Now, if you plug that into your calculator, it will also give you the same thing. All right. All right, number 13. It tells us that z is 6 and y is 4. So we have 6 plus 4 minus 4. So you could automatically notice that these two 4's cancel and you're left with 6. Or, of course, you could say 6 plus 4 is 10 minus 4 more is 6. That would be working left to right since you have both adding and subtracting. Okay? All right, number 14. So we have z equals 6, x equals 1. So we have 4z. So that means we say 4 times 6 divided by 6 plus 1. So we're still doing order of operations here. So parentheses first. 4 times 6 is 24. Bring down whatever is left over. Now we have division and addition. Please excuse my dear Aunt Sally. Remember, division comes first. So 24 divided by 6 is 4. 4 plus 1 is 5. All right, erase some of this. So on number 15, you will notice that you see an exponent, okay? So when you have an exponent, you want to be careful with how you plug in your numbers. So if you notice, it says that m is 2 and q is also 2. So I'm going to plug it in like this. 2 for my q, 2 for my m. And I'm attaching that exponent because if you look, the exponent is just on the m. It's not on the q and m, it's just on the m. If it went to both, it would be on the outside, okay? So now we simplify when you have, just like when you have adding and subtracting together, or when you have multiplying and dividing together, you work left to right. In this case, when we have parentheses and exponents, we're going to work left to right. Okay, so we have our 2. Now I'm actually going to move over here where you can see this better. We have our 2. There's nothing we can do with it. We're going to bring it down. Now we can simplify this, simplifying this exponent. 2 to the 3rd power. That is the same thing as me saying 2 times 2 times 2, which is 8. So now we have a simplified set of parentheses. That right there equals 16. 16 divided by 4 is 4. All right, before we look at, let's see, 16 through 20, I want you to write down a couple definitions. So we have natural numbers. I also like to call those our counting numbers. So that would just be 1, 2, 3, 4, 5, and so on. So natural numbers are not negative numbers. They do not include 0. They start at 1 and they go up. And they, just like you're counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. Number 2, or the second definition, I guess, is your whole numbers. So those are your counting numbers. So your natural numbers. Plus 0. So all you're doing is adding 0 to this sequence of numbers, or series of numbers. All right, the third one is integers. And you may already know this, but I still want you to write it down so you'll have it. So integers are all whole numbers plus their negatives. So I'm just going to make up a random sequence. So let's say -2, -1, 0, 1, 2. It keeps going. It keeps going to the right, but it also goes back to the left. So those are your whole numbers plus all of your negatives. Give you just a second to write that down. All right, next we have rational numbers. And those are numbers that have a fraction or when the decimal stops or repeats. So some examples are 1/2, 3/4. So the decimal for 1/2 would be 0.5. For 3/4 would be 0.75. If we did 2/3, that would be 0.666666667. So you have your repeating decimal of 6. 1/3 would be 0.333, and you know that keeps going. So a rational number is when it's a fraction or when the decimal stops or it has a repeating number. Now we have a number called an irrational number. And I call it a crazy decimal. So it's never ending. It just keeps going. And there is not a pattern. It does not have a repeating number. So things I think about are pi, which you know is 3.14159, and it just keeps going. Or the square root of 2. If you type in the square root of 2 on your calculator, you get 1.41421, and it also just keeps going. Alright, then we have the last one that it talks about. Is a real number. A real number is all numbers that can be written as a decimal. Which I like to think about is really any number that corresponds to a point on a number line. So if I drew a number line, if it could be on this line anywhere, it is a real number. Okay? So, alright, so back to 16 through 20. The number 5. Well, the number 5 is a real number. It is a natural number. It's a counting number. It is a whole number. It is an integer. And it's also rational. Now, you may be saying, well, Miss Ellery, 5 is not a fraction. Well, the number 5 is not a fraction, but 5 over 1 is, and 5 over 1 is 5. 10 over 2 is a fraction, and 10 over 2 is 5. So that is why that is a rational number. Now, you can take your calculators and type in the square root of 90. So I don't know if you know how to do this yet, but to get a square root on your calculator, you hit second, the blue second in the top left corner. And then x squared, which is the 5th button down from the top on the left side. If you type in the square root of 90, you get 9.486832981. Well, that looks like a pretty crazy decimal to me, so I'm going to call that irrational. It's also a what kind of number, though? Can it be on a number line? Yes, it would be between 9 and 10, so it would be on there somewhere. So we're also going to say it's real. It's not a counting number. It's for sure not a whole number. It is not an integer. Irrational and real. Same thing with number 18 and 19. So if you type in the square root of 40, you get 6.32455532. If you type in the square root of 85, you get 9.219544457. Those are all crazy decimals. Therefore, these are both irrational and real as well. All right, now number 20, we have a -7. So negatives are not natural numbers. They're not counting numbers. So they're not whole numbers, but they are integers because it is the negative number. It is rational. And it is real. It's an integer because it's negative. It is rational. Same thing with the 5. I could say -7/1 and get -7. I could say -14/2 and get -7. Okay? So those definitions are important to know. Alright, number 21 through 25, all we're doing is really finding the sum. So remember, the word sum means to add. So we have -3 plus -6. We all know how to do this. -9. We have -7 plus -4. So we have a -11. 3 plus -7. -4. -7 plus 3 plus -4. -8. 7 plus 6 plus -3 is 10. So let's think about our rules here. Okay. What does a positive trump a negative, or a negative trump a positive? Negative always trumps a positive. So when you have a negative and a positive beside each other, remember that negative has a little bit more power. So -3 plus -6 is the exact same thing as me saying -3 minus 6. Or -7 plus -4 is the same thing as me saying -7 minus 4, because this trumps that. Now, another thing that's not on here, but that you do need to know, and I'm going to ask you when I get back multiple times. 2 negatives make a positive. Remember that, okay? So this may have been easy for some of you. This may have been hard for some of you. Either way, I hope you had a little refresher on some basic things before we get started. So I will come back, Friday with another video of your pretest, and then hopefully we can get started on next Monday. Have a great day.